I will share some of the most effective and valuable tips and techniques for consistently producing high-quality products in wave, solder, and post-wave test process in this video. As you know, wave soldering process followed by the post-wave test and inspection can be a complex and challenging process in the printed circuit board assembly. But with the right approach, you can achieve consistent results with over 329 process control points. It's crucial to understand the key process control in wave soldering and post-wave test and inspection in the printed circuit board assembly PCBA process. By the end of this video, you will learn some key process control in one of the post-wave test process to ensure effectiveness of the test process to deliver only good parts to customers. Let's take a dive into the world of printed circuit board assembly wave and test process and explore the areas that require utmost control to achieve consistently high quality products, starting with manual insert to insert the through-hole component on the board, followed by the wave soldering process itself, post-wave visual inspection, integrated circuit test, functional test, panel separations. In this video, we will uncover the secrets of setting up and executing effective functional tests to protect customers from getting faulty products. There are 61 questions in the FCT QPA checklist, and the subsections are the work instruction of the FCT test, the FCT fixture, the FCT test software, the test operation itself, and also the FCT whip tracking and the debug and FA capability. The first section of the functional test QPA checklist is on WI, where you will need to check if there is a revision control test instruction that contains the unique details for the specific product, which includes the part number, has been tested, and the work instruction must be readily available to the test operator, and they follow these work instructions accordingly. You want to check also is the test file name, the test program file name, and the number are also specified in the work instruction itself, and the test file is traceable to a PCBA part number and the revision level, and the test operator has an standard operating procedure for the tester available to them all the times on how to operate the hardware or the test equipment itself, and the operator must be trained and certified against the SOP of the tester, and the operator must be interviewed. You can interview the operators to check if they know the standard operating procedure for the tester and if they follow it. Does the operator requires to log in into the test stations, and this will provide an automatic verification of their test status to ensure that they are the qualified operators to run the functional test. If you want to uncover more secrets about the PCBA and SMT process, make sure to hit that subscribe button and the like button right now. By doing so, you won't miss any of my upcoming videos where I will review another process in PCBA which will enhance your skills in the printed circuit board assembly. The test fixture for the functional test must be identified with a unique name and part number, and we need to check if the preventive maintenance and the calibration stickers on the fixture is current and up to date, or you can also check in the computerized system together, and the preventive maintenance and schedule is also established for each of these test fixture and demonstrate that the preventive maintenance records are up to date. There should also be non-defect found rates used to flag the test station's maintenance schedule. Means that a study on the non-defect found rates, and this will be used to determine if the test station maintenance schedule is suitable, because sometimes non-defect rate is also due to the poor maintenance of the tester itself and not because of the actual products, and we want to eliminate these variations from the test itself. And the goals for the non-defect found reduction is specified for each product and each fixture, and if there is a spare parts for the test stock and the inventory of the spare test part are adequately controlled. All functional test systems must be networked to a server, and the functional test software must be downloaded from a central server with a program call out and at least daily thereafter. The functional test software revision must be controlled for the program changes, and also there should be a control method to log in all the changes to the functional test program and ensure that the method or the record is also available to capture all those changes.
Do you want to learn the secrets of achieving top quality products in PCBA wave soldering and test process? Look no further than my expert course on process control and quality auditing for the PCBA wave and test process at Udemy. With my comprehensive course, you will gain invaluable insights to more than 320 control points from manual insert, wave soldering, post-wave inspection, integrated circuit test, functional test, panel separations required to achieve consistently high quality results, particularly for advanced applications in electronics, automotive, and beyond. Enrolling in my Udemy course is the perfect way to take your skills and knowledge to the next level. You will receive a complete QPA checklist for mastering the PCBA wave and test process audit and control, along with in-depth explanation that cover all aspects of the QPA checklist. Plus, with this affordable online format, you can learn at your own pace and on your own schedule, making it easier than ever to invest in your future. Click on the link below or scan the QR code to enroll today. Unlock all of my courses on Udemy for only $12.99. If you are using a mobile device, simply tap on More to review the special rate course link. Click on the link to view over 15 courses in multiple quality areas offered. For desktop user, you can scroll down and click on the link to download the course list. You can then click in the list to get the special offer rate.
There must be an automated method to load the test program to ensure that it is the correct test program for that particular part number. There must be also a documented procedure on the system to segregate those parts that are untested, fail, and pass bots. And the bots that are awaiting for test must be identified and stored separately according to the procedure or routed via a dedicated conveyor. And the pass and fail bot must be identified and stored separately according to the procedure or routed via a dedicated conveyor. There must be also a verification method on the tester's status at the start of the test that is test with a non-good bot and non-bad bot as a golden sample, and there should be a proper control for both pass and fail golden sample bot with unique tracking ID, expiry date, and also the failure code. And for the verification tester with the fail bot, the operator also needs to record or check the failure code match with the bot intended failure code as well. You can also verify if the manufacturers set up an SPC data collected with a P chart for the failure rate or the pass yield. And if the content of the SPC data is up to date, automated, the best is that it's automatically linked to the test itself, and the out of control data points for the SPC is effectively investigated, and if there is an action that is necessary. And the functional test must also have a trigger point or a goal that established to ensure that the process will be stopped or shut down if the limits are exceeded, means that there could be the presence of abnormal cause. You would like to check if the manufacturers also conduct some kind of a gauge R&R study where applicable for the test system, especially for a complex board. And the test coverage should be calculated by the total number of functions and features versus those that are exercised or tested. The workstation should be properly grounded in compliance to the ESD standards, and the operator must wear wrist strap all the time at the workstation, and it has the best is to have an auto trigger if there is a non-compliance and or violation on the grounding.
I hope you have gained valuable insights into the process control measures required to achieve consistent high quality results in the printed circuit board assembly process. If you have any questions or comment, please leave them below, and don't forget to give this video a thumbs up and share it with others who wants to enhance their skills and shape their future. If you are ready to take your printed circuit board assembly process skills to the next level, enroll in my expert course on Udemy. You will gain access to the complete QPA checklist with in-depth explanation covering all the 329 points, and I look forward to see you in my course.